Okay. We will see, check this again. Nutfa, sperm, embryo, chewing gum, bones, after the bones, lahm. Okay. This part, I think it's difficult for you.
The ectoderm.
This is difficult. I hope you understand this, because if you understand this, we're coming to the real subject now. Until now, we were giving you only information. I hope you understand here, because the subject after this, you won't understand if you don't understand this. This subject here, we must this is the difficult part. The rest is easy.
Germ layer forms, the nervous system is known as neurolation, and this will be the focus of this lecture. Now, neurolation takes
الأعصاب.
place as soon as
أعصاب ببلش after gastrulation.
gastrulation takes place. So let's begin by supposing we have a cross-section of the gastrula stage of embryological development,
هيدا الامبريو عم نطلع من النص.
which is shown in the following diagram. So we take a cross-section and we see the following.
يعني هيدا بعد ما يتلقح البويضة, after the egg is fertilized, after 6 days, this embryo have 3 kinds of cells. 3 kinds. These 3 kinds.
Cells. The purple cells are the cells that make up the
the purple will attach to the wall and it become a placenta after we speak about this.
And the trophoblast eventually forms the chorion as well as the placenta. Now, these are the 3 different germ layers. We have
the embryo is composed 3 kinds of cells, 3 kinds that make all the body parts.
The green cells that make up the endoderm, we have these red cells that make up the mesoderm, and we have these blue cells that make up our
They tell the green is endoderm, the red mesoderm. They giving them names.
ectoderm. Now the endoderm is the germ layer that eventually forms the epithelial layer of our digestive.
Look, it's telling the green forms our digestive systems and this and this and this. When they take an organ they want to make a liver, they take these green cells and they grow it to make an organ. From this green cell, they make, for example, a liver. From the red cells, they make a bone. From the purple cell, they make a skin. Because all the scientists, they are studying this area.
Tract, as well as the lungs, our liver, and our pancreas, and other structures such as the thyroid and parathyroid glands, and the thymus. The mesoderm forms the muscular and
Look, the middle cells, they make the muscles. The cells, they make the muscles.
Skeletal system, as well as the cardiovascular system, the excretory system, and the reproductive system. While the ectoderm is what forms the skin.
Look, this is the endoderm. The 3rd layer makes the skin.
As well as
this stage of embryology, this is the important part of all the embryology and the science in the world. This is the most important part. Because from 8 cells, 10 cells, all the human body is built. It's very quickly. If it continues this speed, formation, a baby may become 2 tons. Look how strong these cells are. They are playing with these cells.
The nervous system. Now,
you see this green, it will make the nervous system.
Before these blue cells can actually organize themselves,
these cells are called stem cells. They do organs. This will we speak about. These are the stem cells. They take the embryo and they take the cells from this embryo. This is the embryonic stem cells. Because this I want you to understand.
And arrange themselves and differentiate into the cell.
They're making the blind seed from this cell. They take the cell that makes the eye and they put it in the eye and it builds the eye. Blinds are seeing now. Everybody see they see which organ is making the ear or the eye or something. They take the stem cell and they implant it and it builds it. We will speak about this.
That ultimately make up the central and the peripheral nervous system of our body, what must happen is a structure known as the notochord.
Before all this happens, a notochord must form, the izam. Without the izam, nothing starts. First, the izam, the bones. After asab, neurolation and muscles.
Must actually form. And the notochord is formed from the cells found in the mesoderm germ layer. So the mesodermal cells basically form a structure known as the notochord. And a notochord is a cylindrical collection, it's a cylindrical rod of cells that runs all the way along the entire length of that developing embryo. So in this diagram, we form the notochord from these red mesodermal cells. So if we zoom in on the following diagram, we get the following picture. And this structure here is the notochord.
Before anything happens, neurolation, asab, muscles, a notochord must form. The bones.
It goes into the board and it comes out of the board and it runs along the entire length of that developing organism. Because remember, this is only a cross-section of that entire developing organism. That's why the notochord looks like a circle. Now, what exactly is the point of the notochord? Well, the cells found in the notochord are responsible for stimulating and inducing the thickening.
Okay, if there is no vertebra, the cells, they cannot stand. Look, a small video here. These are the bones. These are the nerves. These are the muscles. When the bones are formed, the nerves and the muscles go inside the bones and neurolation happens. Izam kasawnaha lahma. This is it. So first the bone. After neurolation, okay. I just put this video to take an idea.
Region here, it would look something like this.
But look, this is the spinal cord, and this is all the nervous system. If you want to move your hand, order comes from here, from the spinal cord, the nerves inside, it comes out. It takes order, it comes to the spinal cord, and it goes to the brain, from your leg. If you give order, it comes from the nervous system, through the spinal cord, there is the nerves, to the leg. It takes the order back, it comes back to like this, the nerves work.
But before we continue on, the person I draw on the right, we are looking at him from a posterior view. We're looking at his spinal cord from a posterior view, from the back.
You see why the bones have to be made first? So that when the bones are made,
I am drawing, we're looking at it from an anterior view. So please know that the cross sections I'm drawing of the spinal cord attaching to this spinal cord. The spinal nerve consists of a ventral root.
you see, the nerves, they go inside the spinal cord. The orders go inside the spinal, there is the nerves that go inside the spinal
root
cord.
And the dorsal root, the back root.
Okay. Now, where were we? The first step, it was nutfa, zygote. The second step, embryo, madara. What is the third step? Embryo, we know, alaqa. After what?
At week 9, your baby has graduated from embryo to fetus.
It was embryo, janine. It became a fetus. It changed. Why it changed? What happened? This is the third stage. Zygote, embryo, fetus. Here, it was inside the wall, the embryo, sucking blood. After here, something is called the placenta, a new organ inside the Beit al-Rahim bit that makes the umbilical cord, al-habl, that starts sucking blood inside the Beit al-Rahim, uterus. Before it was inside the wall of the uterus. Now it's inside, it's tied with the umbilical cord through the placenta. This is the third stage.
She is nearly an inch long and looks more like a baby. Her digestive tract and reproductive organs are formed, but it's still too early for even a skilled technician to tell whether you're having a boy or a girl. This week, your baby might start hiccuping, one of the earliest movements a fetus makes. Soon, sex hormone, testosterone. By the end of 10 weeks, your baby has more than 90% of the anatomic structures present in adults. A boy or girl, but most of the time, a baby's sex can't be detected until 15 or 16 weeks.
Okay.